Hello guys, welcome to a new video, and in this new video we are going to configure IPsec using IKE version 1. And on the video before, we describe what version 1 is and the two phases that IKE uses to form this IPsec tunnel that we're going to create, the site-to-site VPN tunnel. And we are going to be using a router, a Cisco router, and we are going to be using a Cisco firewall over here. So we are going to create an IPsec IKE version 1 tunnel between a firewall and a router. Okay, so whenever you are going to configure this, there are two phases that you need to configure. The first phase is going to be of phase one, and in phase one, the first thing I need to do is you need to create a crypto policy that we're going to create right now. Policy, see if I remember. Oh, it's ISAKMP policy, and it's going to be you give it a number for it, or it's actually a priority number, which is going to be number one. That's the only one I'm going to have. And then we do an encryption, and we are going to be using the encryption is going to be just 3 desks. Then you have to provide a hashing algorithm. We're going to be using MD5. Diffie Hellman group number is going to be number 2. And the authentication is going to be a pre-share key. And then we need to give it a lifetime. And the lifetime is going to be, what is it, 86,400, the highest one. Yep, 86,400. There you go. And this crypto policy parameters need to match on the ASA. So we need to match the encryption and the encryption. So we need to put 3 desks on the other side. We need to put the same hashing algorithm. So we need to put MD5 on the other side. The group number also needs to match. We need to put that on the other side. And the authentication method, if we're going to be using a pre-share key, and also the pre-share key needs to match. Or if we are going to be using a certificate, which we are not, and that needs to match as well. And the lifetime needs to be either whoever is going to initiate the tunnel is going to be the highest, is going to have the highest lifetime. So if this one is higher, then the other one needs to be either equal or lower than this one. It cannot be higher if this one is going to initiate the tunnel, okay? So after we do that, we need to go ahead and create a pre-share key. So our next step is to create the pre-share key. So the way that you do that, you do crypto, ISAKMP again, we're going to do key. If you do a question mark from here, we're going to do the key. We're going to be called CCNP security, which is the exam that I want to take next. Or that I want to take now, right? That's why I'm doing all these configurations. And then we need to tell it which is going to be the peer that we want to authenticate with this key. And our peer IP address is 30.1.1.2. So let's go ahead and do that. There we go. So that is done. Um, and after we do that, so we have configured the phase one. And for the phase one, we're not going to do any show commands now. Let's go ahead and just configure the phase one for the ASA, which is a little bit different than configuring the router. So the way that you do it, you need to do a crypto IKE version 1 enable. You want to enable it on the outside. That's the first thing that you want to do. And then after you do that, I believe you do a crypto IKEv1 policy. We're going to configure then policy 1 for this. And the first thing that you want to do, and we need to match the same as the other one. So we're going to do authentication. We're going to use some pre-share key, encryption, which is going to be, what was it, the encryption 3 desks, the hashing algorithm to provide data integrity is going to be ND5. The different Hellman group number is going to be 2. Am I missing anything? Then we got to do a lifetime, and I want to match it. There we go. So that has been configured. Now after we do that, we want to go ahead and create um, that pre-share key. And the way that you do that is by doing a tunnel group, and you want to provide the same IP address has the peer, which is this one. That's how you do it. 30.1.1.1. The type that we're going to be using is a IPsec LAN to LAN, L to L, which means site to site. And then we're going to do a tunnel group. Um, there we go, tunnel group 30.1.1.1. And we're going to configure the IPsec attributes. And the only attribute that we're going to give it is going to be the pre-share key attribute, right? Pre-share key, CCMP, security. Make sure that it's matching the same one on R1. It is the same one. Okay, great. So they are matching. So we have configured phase one for both devices. So what we have to do next is go ahead and configure phase two. So what we need to do is we need to, let's start with router two. So with phase two, the first thing I need to do is create an extended access list. So let's go ahead and do that. Access list, and we're going to say that it is an extended. We're just going to call it CMAP ACL. And this is what is going to tell it what you want to send to the what do you want to send into the tunnel? What do you want to encrypt? And what I want to encrypt is this one. Whenever a permit IP is coming from the source of this wildcard mask into the destination of 192.168.1.0 wildcard mask, I want it to encrypt it. So whenever a a packet arrives in this router and it has a source of this, right, and a destination of this, I want to encrypt it. That's what I'm just telling it. Okay, and after we do that, we need to go ahead and configure a crypto IPsec or transform set. And we're going to do it like this, and we're going to call it CMAP tset. And we're going to now provide what we want to do. So we want to encrypt using ESP and AES. And on the video before this one, I provided you guys what ESP is in AES. And also we got to do the hashing, ESP with SHA, and we're going to use HMAC as well. There you go. So this encryption and this data integrity right here needs to match on the ASA. So whenever we configure that, we need to make sure that they are matching. Otherwise, we won't be able to form a tunnel. And then after that, we need to tell let that the mode is going to be tunnel. Okay. Now we exit out of here, and now after that, we need to go ahead and create a crypto map. And what the crypto map does is that it combines the access list that we created, the transform set, and also we are going to match that PRP address. And then after we do that, we are going to add it to the interface of IKEv1, which is outside. So let's go ahead and do that. Crypto map. The name is going to be called just VPN. And this one is going to be a sequence of 1, IPsec ISAKMP. And we are going to set the address to it's a set peer to 30.1.1.2, which is the ASA IP address. We're going to set the transform set to CMAP tset, which was the transform set that we created. There we go, CMAP tset. And then we need to match um, the address. We are going to match what we want to encrypt, which is this access list that we created. There we go. So then after all that is set, we need to go ahead and let me see. We need to go ahead and activate the crypto map by adding it into the interface. If we go to interface IKEv1, we're going to do a crypto map VPN. And that's going to turn on ISAKMP. As you can see, it was off. Now it is on. Great. So we are done with the configuration over here on the router. So now we need to go ahead and configure the ASA Phase 2. for the ASA Phase 2, the first thing that we need to do is we need to create an access list, um, and it's just the same as the router, but it's going to be the IPsec. So now the source is going to be this, and the destination is going to be that. That's what I want to encrypt. So let's go ahead and do access list. We're going to call it the same way we call it on the other side. It doesn't really need to match. Permit. We want to permit 192.168.1.0. And remember, guys, that the firewalls do not take wildcard mask. They take subnet mask. And the source is this. Let's see, what did I miss? 10.10.10.0, 255. Always forget that permit IP. Of course I did. There we go. So after that is configured, we need to go ahead and configure how we want to encrypt it. So we do a crypto um, IPsec IKEv1 transform set CMAP transform set. And how do we want to do it? We want to use ESP with AES, the same way we do it on the other side, and then ESP with SHA and HMAC. Right, let me verify that. Yep, ESP with AES to encrypt it, and ESP SHA with HMAC. And there we go. And we don't have to tell it that we're going to use the toner mode because by default, that's what it does. So we don't really need to tell it that. So let's go ahead and now what we need to do is we need to go ahead and combine everything together like we did on the router. So we need to go ahead and create a crypto map. And we're just going to call it the same way, sequence, then IPsec ISAKMP. Where did I miss? IPsec ISAKMP, VPN, IPsec ISAKMP. I don't think we need to do that. Okay, so let's go ahead and do one match address, and we need to match the CMAP ACL, and then we need to go ahead and configure that VPN to set and let's see if I remember. Is it IKEv1 transform set? Let's see. So we put the map, then we put the transform set to CMAP, transform set. Okay, let's see if I'm missing anything. We have the transform set. Let's see if we do the transform set. Set. Looks like it is good. IKEv1. Okay, after we do that, and then we need to go ahead and configure the interface outside. Crypto map has incomplete entries, so what did I miss? Crypto, right? Crypto map, VPN, sequence of one. Oops, I forgot to match. Did I not do the match? I think I did. I did the match. Let me see. Transform set. I did not do the match. Okay, so match, and we are going to match the address to be a CMAP ACL. And then let's go ahead and put on the outside interface. There we go. So what I was missing when it gave me that warning was that It was incomplete because I forgot to do to add the access list. So now after I added the access list and the transform set, um, it looks like it is ready to go. Do we need to do the peer IP address? Let's see. Crypto map VPN sequence number 1 set peer, and the peer is going to be 30.1.1.1. There we go. And then we can just go ahead and add it again just to make sure. There we go. So I did added the peer. I added the interface a couple times, the match, and I did also added the transform set. So we now are ready to go. So this should be not working yet because I need to go ahead into the ASDM. So we are just going to log it into the ASDM, and what we need to do is we need to allow that traffic to come back in. So let's go ahead and launch the ASDM 192.168.1.1. Always trust. Okay. So what we want to do is that whenever um, somebody tries to reach the ASA on the outside interface from this this IP address or with this other IP address, I wanted to automatically allow it in. So let's go ahead and do right here. Let's go ahead and go into firewall. And then first I want to create some objects, network objects. The first object that I want to create is going to be router 1. It's going to be a host 30.1.1.1. And then we're going to do another one, which is router 1 inside network. It's going to be a network 10.10.10.0/24. Great. So now let's go ahead and go into the access rules, and let's go ahead into the outside, and let's add a couple rules. So the first one that I want to add is that I want to allow this router to be able to come in to the destination of the inside network. And I want to allow um, ICMP, and also I want to allow IP, ICMP and IP. Done. And I also want to add another one, which is the router inside, going into the inside network. And I want to allow IP and ICMP. All right, there we go. Apply, send it. So now, if we go into this device and we try to ping 192.168.1.1, we are able to do that. As you can see, we're able to ping from this device to this device. Now let's see if we are able to ping from the ASDM device. From the ASDM into this web device. I mean, we should be able to because it allowed the packets to come back. So ping 10.10.10.2. And then you see it is working. Let me verify that I ping. Well, actually, I want to ping it from this device. So ping 192.168.1.1. So it looks like it is now working. So packets coming in are now allowed in. So I believe this is because, let's put it over here so we can see if it gets activated whenever we configure firewall, service policies. Let's edit this MPF. Let's allow ICMP. So it is still not letting me ping this. Not sure why, because it is letting the ICMP. So let's see what's going on over here. So I'm allow IP and ICMPs. Let me see if I'm able to ping from this web into 30.1.1.2. I'm able to do that. Did I ping? Oh, I ping. I think I pinged the incorrect one. So 192.168.1.2. Okay, there we go. So I was pinging. There is an issue. It's not an issue. It's just what the ASA does. So whenever you try to ping ASA's interface, like the inside interface, it does not allow pings by default. So that's why you need to ping this device over here. So when I pinged that device, I was able to do that. So now, since we're pinging and we're doing all this good stuff, I want to we are done with the ASDM, so we can put this down. If we go into the ASA, what we could do is we can do some verification commands for phase one of the ASA. And the way that you do that, you want to do a crypto IKE. Let me see, is it show crypto IKE? Show crypto IKE version 1 SA. As you can see, there is one tunnel that is active. So it looks like it is working correctly. And the other one for phase two, you can do a crypto IPsec or show crypto. I keep forgetting show crypto IPsec SA. And there we go. As you can see right here, they have encapsulated 23 packets and decapsulated 73 packets. As you can see, take a look at this number, 20, 23 and 71. And now what we're going to do is we're going to ping um, the ASDM, and those packets are going to go up by this many. Okay, I guess that's good. So now let's go ahead into the ASDM. Remember, 23 and 71. Let's do it again. And as you can see right now, it encrypted 37 and it decrypted 87. That means is that it is working. So now if we go into the router, you would just do some show commands for the verification. Show crypto IPsec SA. As you can see right here, 85 and 37 as well too. And let's try to ping 3 times 1, 2, and 3 and dropped it. So now let's go ahead and go back over here. So now this one should be 88 and 37, right? Let's see. There we go. Oh, 88 and 88 and 40 because it was going to go up by 3. As you can see, 88 and 40. So everything is being encrypted and it is being encrypted and decrypted. And one way that you could really see it on live is by doing some debug commands. And the debug that you can do from the router is that you can do some debug crypto ISAKMP. Or actually, let's do a debug crypto IPsec. So that is on. Let's go ahead and ping. And it didn't show anything. Let's go ahead and do a debug crypto ISAKMP. It is on, but I don't see anything happening. Let's go ahead and go into the, oops, did a move, Persian, but it is being encrypted and decrypted, probably because I'm sending too much traffic. Let's go ahead and go into over here and do a debug crypto IPsec SA maybe. Nope. debug crypto IPsec, and let's go ahead and ping. The ASA also doesn't do anything. Let's do IKEv1, and I'm pinging and it doesn't do anything. Oh, you can see stuff going now. There we go. Process. So there's a lot of messages over here. But if you do a crypto or debug crypto packet, let me see, crypto. Is there a crypto packet engine or engine packet? There we go. When you do, let's do an on all first. You turn it off, all of them, and then let's do this one only, and you can see that live. So there we go. As you can see, I am pinging from this device the web one to the ASEM, and you can see stuff is being encrypted, so you cannot really see it. So it is working correctly. And also, if you, let's say, if I'm going to ping 30.1.1.2, nothing is going to be encrypted. That's because it is not matching the access list that we created. The access list is only saying that whenever this lane over here, 10.10.10.0, tries to ping 198.168.1.0 network, then we want to encrypt it. And that's why it only shows whenever I'm trying to reach this network. Also, let's see if this one has the debug crypto engine packet. Let's see if we ping from here. See if we see anything. So we don't see anything. Any of the debugs command are not really working. But one of the other commands that you could do to see both phase one and phase two. This one keeps going. Okay, that's fine. From over here, you can do a VPN session database, and you can do detail. There's no details. Okay. Oh, it's show. So show VPN database, LAN to LAN, or detail, LAN to LAN. There we go. You can see whenever you do that, you can see both phase one and phase two over here. So as you can see right here, Ike, you can see the version one, or not the version one, but phase one, and you can see how it was configured. The Diffie Hellman group was number two. As you can see, we're using port 500 because we're not using NAT. So whenever we don't use NAT, we're always going to use port 500. You can see that we're using pre-share keys. The hashing is MD5. Encryption is 3 des. The lifetime is this many. And for phase two, you can see everything we have configured. AES 128. We're using the toner mode, and the idle time you can see is 30 minutes. So you can see all the good stuff. And from router one, whenever you want to see both phase one and phase two, like we did over here at the same time, which is a really good command. You should know this command, which is show VPN dash session on database detail LAN to LAN. You need to remember that because it's a really good command. Let's try one from router one. And for router one, if you want to see both phase one and phase two, you need to do a show crypto session detail. Show crypto session detail. And when you run that command, show crypto session detail, you can see both phase one and phase two configuration over here. Or it should, let's see. You can see that the session status is up and active. You can see the peer, which is 30.1.1.2, which is the ASA. There we go. So you can see IKE version, we're using IKE version 1, and you can see all that good stuff from here. So I will leave this out for this video, guys. Thank you guys for watching this video. I hope you guys enjoyed this video. And if you guys want the commands that I did, or either the troubleshoot or the verification commands, I will probably leave one on the description below so you guys can see it. So thank you guys for watching, and I'll see you on the next one, guys. And if you guys want to go ahead and follow me on Twitter, you can go ahead and do that at CCNA Daily Tips, where I post all my stuff. And if you don't have a Twitter account, hey, go ahead and create a Twitter account and then follow me. Thank you guys for watching, and I'll see you in the next one, guys. Bye bye.